Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3 for May-June 2022 and the code is 9709/32. Let's move on to question 1. Okay, question 1, solve the equation ln of e2x plus 3 equals to 2x plus ln 3, giving your answer correct to 3 decimal places. Alright, so first of all, I copy the question. Now, since you are giving your answer correct to 3 decimal places, alright, so now here we will just move the ln 3 to the left hand side first. Then later on we will get the solution using calculator. Alright, so then use the formula ln A minus ln B is ln A over B. So from here I will get ln of e2x plus 3 divided by 3 equals to 2x. Now to eliminate the ln, I should take e both sides. So here e2x plus 3 over 3 equals to e2x. Okay, now times 3 to the whole equation. So e2x plus 3 equals to 3e2x. Then this e2x move to the other side. I'll get 2e2x equals to 3. So e2x is 3 over 2. Okay, then take ln both sides to eliminate the e. So I'll get ln e2x equals to ln 3 over 2. So from here, we will have another formula which is ln a to the power of b is b ln a. Alright, so I will move down the 2x. So 2x ln e equals to ln 3 over 2. This ln e is 1. Now your x will be half ln 3 over 2. And since the question is asking for 3 decimal places, so now you use calculator. Therefore, your x will be 0.203. That's the solution for number 1. Question 2. Solve the equation 3 cos 2 theta equals to 3 cos theta plus 2, where the theta defined from 0 to 360 degrees, inclusive. So now 3 cos 2 theta equals to 3 cos theta plus 2. Now, since you have the cos theta and cos 2 theta here, therefore we need to use double angle formula. Cos 2a equals to 2 cos square a minus 1. Now my a is theta. Okay, therefore I will be getting 3 bracket 2 cos square theta minus 1 for the left hand side, and my right hand side will be 3 cos theta plus 2. And now for the left hand side, you need to do expansion to get 6 cos square theta minus 3 equals to 3 cos theta plus 2. And then this 3 cos theta will be moved to the left hand side together with the plus 2. So I will get 6 cos squared theta minus 3 cos theta minus 3, and by moving the plus 2 to the left hand side, then combine with the minus 3, it becomes minus 5. Then equals to 0. So this is a quadratic equation, and now we solve this using quadratic formula because it cannot be factorized. So now your a is 6, b is minus 3, c is minus 5. So cos theta equals to minus b, so minus 3 plus minus square root of b squared, so minus 3 squared minus 4. A is 6, c is minus 5, then over 2a. Alright, so using this formula, you will be getting 2 cos theta value. The first theta value is 1.1965. Another value is negative 0.9695. Okay, so we should realize that cos theta maximum is 1, minimum is minus 1. So that means the first value is ignored. Okay, so our cos theta is negative 0.6965. And now by looking at the interval of the theta, it is from 0 to 360 degrees, means that you can accept all 4 quadrants. So now by referring to the quadrants, cos negative means that it is second and third quadrant for cos negative. So use a calculator to get the basic angle, right? So your theta is inverse cos 0. Let's say theta inverse cos 0.6965, or I will just say inverse cos 6965. Inverse cos 0.6965. This basic angle from calculator is 45.9, which means here is 45.9, and same for the next. And now our angle is counted from the first quadrant, right? So that means the green color will be my two angles. So now my theta is going to be 180 degrees minus 45.9 degrees for the first green angle, and the bigger green angle will be 180 degrees plus 45.9 degrees. Then you will be getting 134.1 degrees and 225.9 degrees. Okay, so these are the solutions for this question. Question 3. The polynomial ax cubed plus ax plus bx plus 3 is denoted by px. So I will write it down. Px is ax cubed plus x squared plus bx plus 3. It's given that px is divisible by 2x minus 1. So when divisible by 2x minus 1 means that the remainder will be 0, or I will say that 2x minus 1 is a factor. So according to the factor theorem, if 2x minus 1 is factor, means that you let 2x minus 1 be 0, then your x will be half, which means p half will be 0. Okay? So when you write p half equals to 0 means that 2x minus 1 is a factor. And when px is divided by x plus 2, the remainder is 5. So according to the remainder theorem, if it is divided by x plus 2, so you let x plus 2 be 0, that means your x is minus 2. But the remainder is 5, which means you are getting p minus 2 is 5. Okay, now find the values of a and b. So now I'm going to substitute these two equations, or these two values, into the equation. So now when I start with p half equals to 0, which means when my x equals to half, right? When you compare, when my x equals to half, this px is 0. So I will get 0 equals to a bracket half cube plus half squared plus b bracket half plus 3. Okay, so when you simplify this, this is 1 over 8a plus 1 over 4 plus 1 over 2b plus 3 equals to 0. And then I will further simplify. It will be 1 over 8a plus half b equals to, right, the constants will be moved to the left hand side or right hand side, move to the other side. Okay, so it becomes negative 13 over 4. I'll let this be the first equation. Now by using p negative 2 is 5, so when p negative 2 is 5, now my px will be 5, and replace the x by negative 2. So I will get a bracket minus 2 cube plus negative 2 squared plus b bracket negative 2 plus 3. So when you simplify, 5 equals to minus 8a plus 4 minus 2b plus 3. Okay, and now again rearrange. So I will get minus 8a minus 2b equals to minus 2. So from here, I can get my b. So first of all, I divide by 2 first. So now minus 4a minus b, or I divide by minus 2, then it will be easier. Okay, I divide by minus 2. So I get positive 4a plus b equals to 1. Hence, I can get my b. My b is 1 minus 4a. This is my second equation. Now I'm going to substitute second equation into first equation. So 1 over 8a plus half of the b. b is 1 minus 4a. That equals to negative 13 over 4. So now do expansion. 1 over 8a plus half times 1 is half. Half times negative 4a becomes negative 2a equals to negative 13 over 4. So 1 over 8a minus 2a, you will get minus 15 over 8a. Then the half will be moved to the right hand side. So becomes minus half. So negative 13 over 4 minus half, you will get negative 15 over 4. So from here, my a is going to be 2. Once the a is found, then you can substitute into the second equation to get the b. So my b is 1 minus 4 times 2. So that means it's minus 7. Okay, so that's the solution for this question. Question 4. The equation of a curve is y equals to cos cube x square root to x, square root sine x. So now I will rewrite the function. It is given that the curve has one stationary point. So stationary points happens when dy dx equals to 0. And this stationary point is in the interval from 0 to half pi. Now find the x-coordinates of these stationary points, giving your answer correct to 3 significant figures. So it means that first of all, we need to differentiate. But before that, I will change this to another form, which is cos cube x. Cos cube x is same as cube of cos x. Alright, then the square root sine x is same as sine x to the power of half. Now I will let my u be cos x to the power of 3. So now my du over dx is going to be moved down to 3. Rewrite the cos x. Degree becomes 2. Right, then you differentiate cos x is minus sine x. This is your differentiation. So then if you want to rewrite, it will be negative 3 cos square x sine x. Okay, so now my v is sine x degree half. Therefore, the dv dx is, bring down the half, rewrite sine x, then the degree you need to minus 1. So half minus 1 is minus half. Then don't forget to differentiate sine x to get cos x. So from here, since the degree is negative half, I can move it down, okay, and combine with the half. So it means you are getting cos x over 2 square root sine x. So from here, my dy dx, it will be u dv dx. Alright, so cos, instead of writing cos x cubed, I can write cos cube x. Then dv dx is cos x over 2 square root sine x. That is my u dv dx plus v du dx. v du dx. So instead of writing degree half of sine x, I will just write square root sine x. Then multiply by negative 3 cos square x sine x. Okay, so now we need to let dy dx be 0 because we need to get the x-coordinate of the stationary point. So now I will let it be 0. At the same time, I will just make it to the same denominator for both terms. Right, so the first term will be cos degree 4x. And then for the second term, since I introduced the 2 root x, the denominator of 2 root x to the second term, that means I'm multiplying 2 root x to the numerator of the second term as well. So it means that 2 root sine x multiplied to the existing second term. Alright, so now when we need to solve this equation, the denominator will be 0. So I will get 0 equals to cos degree 4x. So now square root sine x times square root sine x, it will be sine x. Okay, and don't forget there's a minus 3 here. Minus 3 times plus 2, it becomes minus 6. So I will write minus 6. So I write minus 6. The square root becomes sine. Then I still have the cos square x. And don't forget there's one more sign at the back. So the sign with this sign becomes sine squared. So I'm getting this now. But we need to find the x coordinate. Okay, since you have the sine and cos, right? So I will factorize a common term, which is a cos square x. Then I will get cos square x minus 6 sine square x, then equals to 0. Then now cos square x equals to 0, because when you are getting the products of two factors equals to 0 means one of them must be 0. So either cos square x equals to 0 or the second term, cos square x minus 6 sine square x equals to 0. Okay, so now let's look at the question. The x is between 0 and pi over 2, but not inclusive both. So when not inclusive both means that we don't get any solution for the cos square x equals to 0, right? Because when cos square x equals to 0, your x will be 0. Then cos square x, it will be 90 degrees, okay, or pi over 2. This is 3 pi over 2. So you only get these two solutions, but we cannot accept exactly pi over 2, which means this one no solution or omitted. Okay, so now we need to refer to the second equation to get the solution. So now 6 sine square x equals to cos square x. So you can divide the whole equation by cos squared. So I will get 6 tangent square x equals to 1. Therefore, your tangent square x equals to 1 over 6. And now we will only accept tangent x is positive 1 over 6 because it's mentioned that your x is between 0 and half pi. Right? So now from here, your x will be 0.388. So to get this x value, remember to change the mode of the calculator to radians. Okay, so that's all for this question. Now, question 5. By sketching a suitable pair of graphs, show that the equation ln x equals to 3x minus x squared has only one real root. So if you are sketching a pair of graphs, means that you should have just one intersection point, because one intersection point means one real root. Alright, so first of all, I will sketch ln x. So we know that ln x is in this shape. Here is 1. Right? So when you need to sketch a quadratic graph, y equals to 3x minus x squared, you will let the y be 0. Then I can factorize the x. You will get x times 3 minus x, which means your x equals to 0 and x equals to 3, the y will be 0. Okay, then the y will be 0. So now, let's say here is 0. This is the first point. This is 2. This is 3. This is second point. And now from here, we know that the graph will have a maximum point because the coefficient for x squared is negative, right? So now, since the distance here 0 and 3, the distance between 0 and 3 is 3 units, then the maximum points will happen at x equals to 1.5, which is symmetrical. So, alright, so now just simply sketch. Let's say this is a quadratic curve. So the y coordinates, the y coordinates of the maximum points of the quadratic is not important. Alright, so this is the y equals to 3x minus x squared. Here is x, here is y. And then this is 3. So from here, there's only one intersection point. Therefore, the equation has only one real root. So from the graph, right, from the graphs, there is only one intersection point. Hence, the equation ln x equals to 3x minus x squared has only one real root. Okay, now B. Verify by calculation that the root lies between 2 and 2.8. So now I will move the right hand side terms to the left hand side. So ln x minus 3x plus x squared equals to 0. And the next step is to apply the sign change rule. Okay, so now I will let this be fx ln x minus 3x plus x squared. And now when you need to prove that or verify that the root lies between 2 and 2.8, basically you just replace the x by these two values. So f2 is ln 2 minus 3 times 2 plus 2 squared. And then the value is negative 1.31, which is less than 0. The next is f2.8, which is ln 2.8 minus 3 times 2.8 plus 2.8 squared. And this value is negative, this value is 0.470, which is greater than 0. So now, that is, or you can just write since f2 less than 0 and f2.8 is greater than 0, there is a sign change. Hence, the root lies between 2 and 2.8. Okay, so we already solved this question. Now C, use the iterative formula x of xn plus 1 equals to square root of 3xn minus ln xn to determine the root correct to 2 decimal places. Give the results of each iteration to 4 decimal places. Okay, so now from here, we know that the x lies between 2 and 2.8, which means you can let the initial guess, the x0, be 2 or 2.8, or you can just take any values in between. Alright, so I will take the middle value, which is 2.4. So now, let x0 be 2.4. Then my x1 is square root of 3 bracket 2.4 minus ln 2.4. Then now I will get 2.5149. So when you compare 2.4 and 2.5149 is very much difference because we need 2 same decimal places after you round up the third one. So x2 will be square root of 3 bracket 2.5149 minus ln of 2.5149. So here is 2.5734. So when you compare, again, this is 5.1, here is 5.7. So we cannot make the conclusion now. So now just just continue with the formula, the iterative formula. So 3 bracket 2.5734 minus ln of 2.5734. So then the answer is going to be 2.6029. So when 2.6029, again, when you check, previous was 2.57, now becomes 2.67. So, sorry, 2.60. So it means that we still need to continue this. So now becomes 3 bracket 2.6029 minus ln of 2.6029. And now it becomes 2.6176. Okay, so we need to continue. x5 equals to square root 3 bracket 2.6176 minus ln 2.6176. So now becomes 2.6250. Okay, so now when you check, here when you round up the third one, it becomes 63. But the previous one, when you round up the third decimal place, it becomes 62. So need to continue. x6 square root 3 bracket 2.6250 minus ln of 2.6250. This becomes 2.6287. And now when you compare, right, first two decimal places are 62, but when you round up the third one, it becomes 63. So it's same as the previous. Therefore, we can get the answer right now. So my final answer, the x is approximate to 2.63. Okay, so that's the solution. Now question 6. The variable x and y satisfy the differential equation. dy dx is x e y minus x when x equals to 0, y equals to 0. So now A, solve the differential equation obtaining an expression for y in terms of x. So now dy over dx is x e to the power of y minus x. So for this case, before you decide what to do, first of all, the e to the power of y minus x, you can split it into two terms. We have a formula. E power a minus b is basically ea over eb. So now by applying that, I will get ey over ex. Okay, and then now obviously we can solve this using separable variables. So keep all the y on the left hand side. Means that I need to move the ey to the left hand side now. I will get 1 over ey dy. Then I have to move my dx to the right hand side. I will get x over ex dx. Then integrate both sides. Okay, so now your ey and ex are the denominators. So better to move up first before we integrate. So when I move up, I will get integrate e minus y dy. And on the right hand side will be integrate x e minus x dx. Alright, so for the left hand side to integrate exponential should be no problem. But for the right hand side, you have x together with the e. So for this case, we need to apply the integration by parts. So now our u is x. Okay, I will write next line. Our u is x. Du dx is 1. Then dv dx is e negative x. Then the v is negative e negative x. Alright, so integrate e negative y is negative e negative y. Okay, because you are rewriting the whole e and then divide the differentiation of minus y. That is how I get the minus here. Now for the right hand side, use the by parts formula. By parts formula is u dv over dx. It is u dv. It is uv minus integrate v du over dx. Okay, this is the integration by parts formula. So I will get x times the v. Okay, so that is negative xe minus x. That is my uv minus integrate v du dx. So when you multiply by 1, you are getting back the v, which is integration of negative e negative x dx. So now from here, right, I have to integrate the last term. So I will get negative x e negative x. Minus minus is a plus. So when you integrate e negative x, it becomes negative e negative x, then plus c. Left hand side remains. So now, before we proceed, refer to the x and y values. X is 0, y is 0. We need to get a c now. So when x equals to 0, y equals to 0, I will get negative e 0 equals to, the first term is 0 because of the x. Then second term plus and minus is minus e 0 plus c. So basically the negative e 0 is the same as the right hand side. Right, these two will be cancelled off, which means your c is 0. So once you get c equals to 0, substitute back into this equation or this solution, I will get minus e minus y equals to minus x e minus x. Plus and minus is minus e minus x. And then when you refer to the question, now we need to get y in terms of x, which means we need to eliminate the e. So first of all, we multiply or we divide the whole equation by negative. So I will get e negative y equals to x e negative x plus e negative x. And then to eliminate the e, we are going to take ln both sides. So ln e minus y equals to ln of all the terms on the right hand side. And then according to the formula, ln a to the power b will be b ln a. So ln e to the power of minus 1, it becomes minus y ln e. Okay, but then for the right hand side, we cannot split because it is ln of plus, right? So I will just remain the terms on the right hand side, and ln e is basically 1. So here is 1. And now we need to get y in terms of x. Therefore, I will just move them, or I will just times the whole equation by minus, right? Or you can say you move the minus to the right hand side. It will be the same. So y equals to negative ln x e minus x plus e minus x. Right? So basically for the right hand side, if you want, you can further simplify because we notice that the e is in common. So I can factorize the e minus x bracket x plus 1. So once you factorize, then you can simplify because it becomes ln of the multiplication. So now ln ab, it will be ln a plus ln b. Okay, so now I further simplify negative ln e minus x plus ln x plus 1. And now we know that ln e minus x, the minus x can be brought down. So here becomes minus x ln e plus ln of x plus 1. Then ln e is 1. Okay, this is 1. And now you can bring in the minus. So now it becomes x minus ln of x plus 1. So this will be your final answer. Alright, so now the next part. Find the value of y when x equals to 1, giving your answer in the form of a minus ln b, where a and b are integers. Okay, so now I will rewrite my solution. Y is x minus ln of x plus 1. So y is x minus ln of x plus 1 when x equals to 1. My y is 1 minus ln 2. Okay, so it is exactly the same as a minus ln b. And a and b are integers. So that's all for this solution. Okay, question 7. The equation of a curve is x cubed plus 3x squared y minus y cubed equals to 3. Then show this dy dx. So now x cubed plus 3x squared y minus y cubed equals to 3. To get dy dx means that you are differentiating the whole equation with respect to x. So firstly, x cubed becomes 3x squared. For second term, alright, you have two terms actually. It is the multiplication of two terms. The first term is 3x squared, the second term is the y. Therefore, we need to differentiate this using products rule. So keep the first term, which is the u, differentiate the y with respect to x. So when you differentiate the y with respect to y, it will be 1. Then multiply by differentiate the y with respect to x, it will be dy over dx. Plus, keep the y, differentiate 3x squared, it becomes 6x. Then the third term, negative y cubed. And again, when you differentiate negative y cubed with respect to y, you will be getting negative 3y squared and multiply by dy dx. Okay, then right hand side will be 0 because it's a constant. Now, to get dy dx, group the dy dx first. Okay, but first of all, you can divide the whole equation by 3, right? So here becomes x squared plus x squared dy dx plus 2xy minus y squared dy dx equals to 0. Then, for the second and third term, you keep it on the left hand side and at the same time factorize the dy dx. So I will get dy dx times x squared minus y squared equals to, so the rest of the terms will be moved to the right hand side. So I will get negative x squared, negative 2xy. Okay, and now we need to prove this. So next step is going to be the division. You move the brackets on the left hand side to the right hand side. At the same time, for the right hand side, since you have both minus, I may factorize a minus, then it becomes minus of x squared plus 2xy. Then divided by x squared minus y squared. But then when you refer to the given answer, right, there is no negative for the numerator. So means that this negative will be moved to the denominator. So when I move to the denominator, I will get x squared plus 2xy. So this negative, you move to the denominator and multiply with the minus y squared first. So it becomes positive y squared. Then the minus multiplied by x squared, it becomes minus x squared. So this is our solution for A. Okay, now B. Find the coordinates of the points on the curve where the tangent is parallel to the x-axis. So when tangent is parallel to the x-axis, means that the dy dx equals to 0. Means dy dx equals to 0. Okay? And now you need to find the coordinates of the points. So we need to let this dy dx be 0. So I will rewrite this dy dx first. So now my dy dx is x squared plus 2xy divided by y squared minus x squared. When this is 0, right, I just need to consider the numerator equals to 0. So x squared plus 2xy equals to 0. Then from here, we may factorize the x, and you will get x times x plus 2y equals to 0. So you either get x equals to 0 or x plus 2y equals to 0, means x equals to minus 2y. Okay, now let's look at the question. Coordinates of the points means that more than one point here. So now I need to rewrite my curve equation. Okay, because we need to find the coordinates of the points on this curve. So x cubed plus 3x squared y minus y cubed equals to 3. So when x equals to 0, I will get first two terms equals to 0 because of the x. Then minus y cubed equals to 3. Therefore, my y cubed is negative 3. And now I will get my y is cube roots of negative 3. Okay. So the question says coordinates of the points, means that I can leave my answer in exact form, which is cube root of minus 3. Cube root of minus 3, yes. Okay, then the next is, so I get point equals to 0 cube roots of minus 3. This is my first point. Then my second point happens when the x equals to minus 2y. So now I'm going to substitute this into my curve equation. So minus 2y cubed plus 3 times minus 2y squared, which is my x squared, multiplied by y minus y cubed equals to 3. So cube of minus 2y is minus 8y cubed. And then this is going to be 4y squared. 4 times 3 is 12. So 12y squared times y. So y cubed minus another y cubed equals to 3. So the left hand side total is going to be 3y cubed. Alright, so now my y cubed is 1. Therefore, my y is 1. So from here, I can get my points. So basically, I have 2 points. 0, root 3, root negative 3, cube root negative 3. And then another one will be when my x, sorry, I haven't found my x yet. My x is minus 2y. Okay, so from here, x is minus 2y. So now my y is 1. So y is 1. That means x is minus 2 times 1, which is minus 2. So I will get minus 2, 1. So these are my 2 points. Alright. So now question 8. Let fx be x squared plus 9x divided by 3x minus 1 multiplied by x squared plus 3. So express fx in partial fractions. So, alright, x squared plus 9x divided by 3x minus 1 multiplied by x squared plus 3. So first of all, when we observe this rational function, this is basically proper rational function because the degree of the x in the numerator is less than the total degree of the x in the denominator. That means we can find the partial fractions directly. So now, the first factor in the denominator is linear. Therefore, it is a over 3x minus 1. And then the second factor in the denominator is a quadratic, but it cannot be factorized. Hence, your numerator is constant. Oh, sorry, it's a linear function, which is bx plus c. So now, when we need to get the partial fractions, now we need to get the same denominator as in the left-hand side. Therefore, I multiply the first term. So when you compare, I have the first factor. I need to multiply by quadratic factor and divide by the same term. Plus with bx plus c over x squared plus 3. So now you have a quadratic factor. That means you need to multiply by linear factor. So 3x minus 1. Now, I will rewrite my left-hand side. So once you are in this step, basically the next step is to cancel off all the denominators because they are the same. Right? So now I will just refer to all my numerators. Left-hand side will be x squared plus 9x. Right-hand side, the first term is a times x squared plus 3. The second term is going to be bx plus c multiplied with 3x minus 1. That's why I put a bracket for the bx plus c. Okay, now, next step is to get all the unknowns, the ABC. To find this, you can just use, I will use the substitution method, means that I will let the factor be 0. So I will let 3x minus 1 equals to 0. Hence, my x is 1 over 3. Means that I have to replace all my x by minus 1 over 3 in the previous equation. Okay, so it means that now 1 over 3 squared plus 9 times 1 over 3, which is my left hand side. Right hand side is a bracket 1 over 3 square plus 3. But then for the next step, it's going to be 0 because I already let this factor be 0, the 3x minus 1. So for the left hand side, you will get 1 over 9 plus 3 equals to a bracket 1 over 9 plus 3. So you will find that it will be exactly the same. So I can cancel off. Means that you are dividing the whole equation with these two terms. Means now my a is going to be 1. Okay, so now the next x value, by right we need to let this quadratic be 0. But then x squared plus 3, the x won't be 0. Okay, therefore you can't find any x from this quadratic factor. Then you can just let x be any other numbers and let it be 0. Okay, so left hand side will be 0. Right hand side I will get a bracket 0 plus 3 is 3 plus b times 0 is 0. Then I just get c bracket 3 times 0 is 0. Then 0 minus 1, I will get minus 1. So now my c, I will move it to the left hand side. It becomes 3a. So now my a is 1 from the previous calculation. So it becomes 3. Okay, so 3 times 1 is 3. Now then you can let x be any other numbers. I will let it be 1. So left hand side 1 squared plus 9 times 1 is 10. Alright, so a bracket 1 squared plus 3, which is 4, plus b times 1, I get b, plus the c. C I will replace by 3. Bracket 3 times 1 is 3, it's here. Then 3 minus 1 is going to be 2. Alright, so now 10 equals to 4a. My a is 1. Then plus 2b plus 6. So my 2b, okay, now when you calculate the right hand side, this is 10. Left hand side also 10, means that you can cancel off. So now when you cancel off all the terms, means the left hand side left 0, right? Because no more term. So 2b equals to 0. Hence your b is going to be 0. Right? So once you have found the ABC, basically you just need to substitute back into this general form. I will write x squared plus 9x over 3x minus 1 multiplied with x squared plus 3 equals to a over first factor. My a is 1 here. So 1 over 3x minus 1 plus, okay, remember our general form bx plus c. So now my b is 0. So it means that 0x no need to write. Just write plus c. The c is 3. So 3 over x squared plus 3. So that's all for the partial fractions. Right. Now hence find the integration. So now integrate 1 to 3 fx dx is basically integrate 1 to 3 the partial fractions. So 1 over 3x minus 1 plus 3 over x squared plus 3. Dx. And now you need to give your answer in the simplified exact form. Okay, so for your information, right, so the first one, when we integrate, is going to be ln, right? So now I can split it into two integrations. To use the ln, because the degree of the x in the denominator is 1, that's why you are advisable to use the ln. So of course you have to check first whether it works or not. So differentiate 3x minus 1, it is 3. So when you compare with the original question, which is 1, I need to times another 1 over 3 outside to make it to 1. So now this whole integration is exactly same as the previous. Alright, so that's all for the first. Now for the second, because of the x squared, you cannot use the ln. Right, the reason is because when you differentiate x squared plus 3, you will get 2x. There's no x in the numerator. You are not allowed to multiply by x like what we have done for the first integration. So for this case, you need to use the inverse tangent formula. So now we have a formula, integrate a over a squared plus x squared dx. That is inverse tangent x over a plus c. But since there is no, if you want to make it to the numerator, you want to make the numerator be 1, this a will be moved to the other side. So it becomes here 1 integrates 1 over a squared plus x squared dx. It becomes 1 over a inverse tangent x over a plus c. So I'm going to use this formula. But of course, I have to change to a squared plus x squared in the denominator first. So I will change to x squared plus the 3, I change to square of square root 3. Square of square root 3, yeah. Then here dx. Okay, the 3 I will move out. And then here is 1. Numerator is 1. So once I have written in this form, it is a similar form as in the formula. Okay, so now I will use the formula right now. So the first integration is 1 over 3 ln of 3x minus 1. Okay, the second integration is going to be plus 3. It will be 1 over a. Now my a is root 3, square root 3. So 1 over square root 3. The inverse tangent x over my a. A is again square root 3. And now I will consider the limits, because they are sharing the same limits, 1 to 3. Okay, so next is just to replace the x values. Firstly, we replace the x by 3. So 3 times 3 is 9. 9 minus 1 becomes 8. Plus, okay, here 3 times 1 over root 3. You can just simplify to square root 3. Then inverse tangent, again 3 over square root 3 here. Right, 3 over square root 3 is square root 3. Then minus, when the x is 1. So I will get 1 over 3 ln 3 times 1 is 3. 3 minus 1 becomes 2. Then plus 3 multiply, it becomes root 3. Inverse tangent 1 over square root 3. Right. So now we need to simplify, because it's mentioned simplified exact form. So the ln 8, right? So here ln and ln I will combine. It will be 1 over 3 ln 8 minus ln 2 plus square root 3. I will combine the square root 3 here, second and fourth term, but don't forget there is a minus. So inverse tangent root 3 is basically pi over 3. Then minus, okay, after you have factorized the square root 3, you still have inverse tangent 1 over square root 3. Inverse tangent 1 over square root 3 is pi over 6. So now, use the formula. Ln a minus ln b is ln a over b. To simplify the first term, the first bracket, I will get 1 over 3 ln 8 over 2. Then plus square root 3. Pi over 3 minus pi over 6, it will be 1 over 6 pi, or pi over 6. So then the first term, right, I will simplify. It becomes 4. Okay, for the 8 and 8 over 2. So I will get, first term will be 1 over 3 ln 4. Then second term will be square root 3 times pi over 6. So I will rewrite. Then I will get square root 3 over 6 pi. Okay, so that's the simplified exact form. Okay, now question 9. The lines L and M have vector equations r equals to minus I plus 3j plus 4k plus lambda of 2I minus j minus k. And the second line, this is the line M, is r equals to 5I plus 4j plus 3k plus mu of ai plus bj plus k, where a and b are constants. Now, part A, given that L and M intersect, show that 2b minus a equals to 4. Okay, so when they are intersecting means that the R1 equals to R2. Okay, first R equals to second R. So now I will write RL equals to RM. So I will express vertically or write down all the components. So the first one is minus I, right? So here I will get minus 1, 3, 4 plus lambda bracket 2 minus 1I minus 1k equals to 5I, 4j, 3k plus mu of ai, bj, and 1k. Okay, let me check. Alright, a lot of space. So now, from here, I will equate the row by row. So minus 1 plus 2 lambda equals to 5 plus mu a. I open all the brackets. Then the second row, 3 minus lambda equals to 4 plus mu b. Third row, 4 minus lambda equals to 3 plus mu. Alright, so I'm getting 3 equations. So now to show this, 2b minus a equals to 4. Right, I will eliminate the lambda by using third equation minus second equation, because I need to keep the mu and need to keep the a and b. So when I minus 4 minus 3 from the left hand side, it will be 1. The minus lambda, you minus another minus lambda, will be 0. 3 on the right hand side, 3 minus 4 will be minus 1. Then I will get mu minus mu b. Right, so I will just write mu bracket 1 minus b. That will be better. Then now I need to eliminate the mu. Means that now 2 equals to mu brackets 1 minus b. Hence my mu will be 2 over 1 minus b. This is my fourth equation. And just now we used the second and third equation to solve for the mu. Now I will substitute this, or I will just simplify first. So the third equation I multiply by 2. Okay, then I will simplify with the third for the first equation. So the third I times 2 because I want to get 2 lambda. So I will get 8 minus 2 lambda equals to 6, because the third equation is multiplied by 2 plus 2 mu. This is my fifth equation. So now instead of using third and first to solve the next equation, I am using fifth because the fifth comes from third. So now I have plus 2 lambda from the first equation and minus 2 lambda from the fifth equation. So to eliminate the lambda, I will plus these two equations together. So first plus fifth. So left hand side, minus 1 plus 8 will be 7. So the lambda will be cancelled off. 5 plus 6 will be 11 on the right side. Then mu a plus 2 mu. So I will factorize the mu. I will get a plus 2. Alright. So from here, I will get my mu. So move the 11 to the other side, becomes minus 4 equals to mu of a plus 2. And now I get my mu. My mu is going to be minus 4 over a plus 2. This is my sixth equation. Then now I can equate 4 and 6. So 4 equals to 6 because both also mu. So 2 over 1 minus b equals to minus 4 over a plus 2. Alright, so now let's look at the question. We need to solve, you need to show 2b minus a equals to 4. So now cross multiply, 2 brackets a plus 2 equals to minus 4 brackets 1 minus b. So do expansion, 2a plus 4 equals to minus 4 plus 4b. Alright, I need 2b minus a. So means that my 2a should move to the right side. So I will get 4b minus 2a. Okay, here moved. This minus 4 moved to the other side. It becomes 8. And now, when you look at the answer here, I need to get 2b minus a. Means that I need to divide the whole equation by 2. So I will get 2b minus a equals to 4. Alright, so I have shown the result. Okay, now B given also L and M are perpendicular. Find the values of A and B. So when L and M are perpendicular, let's say this is the L, this is the M. Alright, which means the direction vector of the L and the direction vector of the M, let's say this is the BL, this is the BM. The dot product of these two vectors will be 0 because of the perpendicular properties. Right? So I will start with BL equals dot BM equals to 0. So now what is the BL? BL, you refer back. This is the L, right? This is the L. B is this. So 2i minus j minus k. I will just write 2i minus j minus k means 211 dot direction vector of the line M, it will be AB1. Alright, because all these are the coefficients for the components. So AB1 equals to 0. So now this is the scalar product. Therefore 2a plus minus b is minus b, plus minus 1 is minus 1 equals to 0. So basically you just multiply and plus all together. So from here I will get b equals to 2a minus 1. Alright, but the question asking for values of a and b. So to solve this equation, since you have two unknowns, we need another equation from the previous part. Alright, so 2b minus a is 4. So I'll let this be the first equation. So from a, 2b minus a equals to 4. This is my second equation. So I substitute first into second. I will get 2, my b will be replaced by 2a minus 1, then minus another a, then equals to 4. So from here, when you do expansion, the left hand side will be 4a minus 2, then minus a equals to 4. 4a minus a is 3a. The 2 move to the other side becomes 6. Hence my a is 2. Okay. Once you found the a, then you can find the b from the first equation. So from first equation, my b is 2a. A is 2, then minus 1. That means you are getting 3. Alright. So that's the way to solve this question. Okay, now when a and b have these values, find the position vector of the points of intersection of L and M. Okay, this part we have to refer back to the first part. Alright, so we know that when they are intersecting, the mu equals to 2 over 1 minus b. So once you have found the mu, then you can find the point from the second line. Alright, so now I will use mu equals to 2 over 1 minus b. So my a is 2, b is 3. My mu is 2 over 1 minus b, which means that is 2 over 1 minus 3, which is 2 over negative 2, then I get minus 1. Okay, so now I will substitute this into my Rm. So it will be, okay, go back to the question here, 543 plus mu AB1. So 543 plus mu is minus 1, then AB1, 2, 3, 1. Then that will be 5, 4, 3. Plus and minus is minus 2, 3, 1. And then I will get 3, 1, 2. Okay, so that is the position vector of the point of the intersection point. Equals to 3, 1, 2. Or you can say it is same as 3i plus j plus 2k. So you can leave your answer in first form or second form. Alright, so that's all for the question 9. Now for question 10. The complex number minus 1 plus square root 7i is denoted by u. It's given that u is the root of this equation. Now find the value of k. So now we need to substitute the x by the given u because that is the root. Root means the x value. So now your x is minus 1 plus square root 7i. Right, so 2 brackets minus 1 plus square root 7i cube plus 3 times minus 1 plus square root 7i squared plus 14 times minus 1 plus square root 7i plus k equals to 0. So from here, when we need to do expansion for the cube, you may use the Pascal triangle. So 1, 1, 1, this is for a plus b degree 1. But when a plus b degree 2, it will be 1, 1. Then you plus together, it will be 2 here. Then for degree 3, Pascal triangle, you plus together is 3. Here plus together is 3. So all these are the coefficients for the terms. So with this, I will get 2 bracket minus 1 cube because the coefficient for first term is 1. Then plus 3 bracket minus 1 squared. Then square root 7i degree 1. Then the next coefficient is 3. So 3 brackets minus 1 degree 1 square root 7i degree 2 plus the last term, the coefficient is 1. So square root 7i degree 3. So that's the expansion for cube. And then plus 3 bracket for the squared, you use the formula quadratic expansion. A plus b squared is a squared plus 2ab plus b squared. So from here, I will get minus 1 square plus 2 bracket minus 1 square root 7i plus square root 7i squared. And then here just direct expand. Minus 14 plus 14 square root 7i plus k equals to 0. Okay, next is to simplify all the terms. So I will get 2 bracket minus 1 cube is minus 1. Then the next term is going to be plus 3 square root 7i. And then now for the third term, I square is minus 1. So minus and minus becomes plus. Therefore, 3 times square root 7 squared, it is 21. So I will change to 21. And then lastly, cube of square root 7i cube. Okay, I cube is I squared times I. So I squared is minus 1. So therefore, this is minus I. So I will get minus 7 root 7i. So for the second expansion, I will get 3 bracket 1 minus 2 root 7i plus 7i squared. So I squared is minus 1. Therefore, you will get minus 7. And then lastly, minus 14 plus 14 root 7i plus k equals to 0. Okay, so now again do expansion. You will get minus 2. And then, okay, I can simplify first. See here, 21 minus 1 is 20. 20 times 2, I will get 20 times 2 is 40. Okay, then here 3 square root 7i minus 7 square root I minus 7 square root 7i is negative 4 square root 7i, means when I multiply by 8 means that it will be minus 8 square root 7i. Right, so here 1 minus 7 is minus 6. Minus 6 plus 3, minus 6 times 3 is minus 18. Then 3 times minus, it will be minus 6 root 7i. Then the rest just copy. Okay, now when we simplify, 40 minus 18 minus 14, it will be 8. Okay, then minus 8, 7, square root 7i, minus 6 means it's minus 14 square root 7i, and together with this 14 you will get 0. Then just left plus k equals to 0. Hence, my k is minus 8. So that is how we solve this question. Now, B, find the other two roots of the equation. So when you look at the question, we will find that the coefficients are, all the terms are constants. I would say the coefficients are constants. Means that you will have conjugate for the root. Okay, you will have another root as the conjugate of this u. So my conjugate is going to be minus 1 minus square root 7i. So now my u1 is minus 1 plus square root 7i. Then my u2 is going to be minus 1 minus square root 7i. So this u2 is the other root. But then now you need to find another two roots. Therefore, now I need to get the factors first. So x minus the root, the first root, multiplied by x minus the second root, before I perform the polynomial division. So when I do expansion, x squared, then minus 1 minus square root 7i x, right? Then minus 1 plus square root 7i x, and then this is conjugate. Minus minus is a plus. Remember, we have a conjugate. Let's say a minus b times by a plus b. It will be a squared plus b squared, which means I will just write minus 1 squared plus square root 7 squared. So from here, it will be x squared to expansion plus x. Don't forget the x outside. Then here plus square root 7 xi. Here is also x, so plus x. Then this is minus square root 7 xi plus 1 plus 7. So now I will get x squared. Okay, the I will be cancelled. Then it's just a quadratic factor. So here x plus x, 2x. Then plus 1 plus 7 plus 8. So now once you get the quadratic factor, we can just perform the long division. So now I will rewrite my equation, okay, and replace the k by minus 8. So you will get 2x cubed plus 3x squared plus 14x minus 8. So here 2x cubed plus 3x squared plus 14x minus 8. Now to get 2x cubed from x squared, you need to multiply by 2x. So 2x cubed plus 4x plus 16x. When you multiply 2x to all these terms, then you minus 3x squared minus 4x squared is, okay, this is squared. 3x squared minus 4x squared is minus x squared. 14x minus 16x is going to be minus 2x. Then bring down the minus 8 and multiply by minus 1. So here minus x squared minus 2x minus 8. So from here, I know that's my roots, okay, my factors. Another factor is this, 2x minus 1. So now the other two roots equals to the conjugate minus 1 minus square root 7i, and this is my another factor. So when I let this be 0, my x is going to be half. Okay. Now see, On an argon diagram, sketch the locus of points representing complex numbers z, satisfying the equation. So now I will write z minus 1 plus square root 7i equals to 2. So from here, right, you should understand that the minus 1 plus square root 7i, this is the complex number that representing the center. Okay, so the radius is 2. So center is at minus 1 square root 7, and then the radius is 2. So now we need to draw a circle. This is a circle. So now okay, let's say here is minus 1. Square root 7 is basically 2 point something, right? So here is 1, let's say here 2, here 3, here 4, and then here is 5. Alright, so let's say here is square root 7. The radius is 2, means it will be touching here, and then plus another 2 means somewhere here, and then plus 2 units. Let's say here is 1, and then go to left hand side for another 2 units. Here is minus 3. Right, so now my circle, so please draw a smooth circle. Right, so let's say this is my circle, so the equation will be this, right? So this is the real axis, and the vertical will be imaginary axis. Okay, so done this part. Now determine the greatest value of the argument z for points on this locus, giving your answer in radians. Okay, where is the greatest argument? So basically the greatest argument is here. Alright, so it must be touching the point. That's why you need to draw using ruler, then it will be more accurate. Let's say for example, okay, right? Okay, let's say for example it's like this. It's supposed just to touch one point. Okay, let's say for example like this. Right, so okay, so now the greatest argument is over here, just to touch a point. Okay, so how to get this? It obviously is half pi, which is this part, right? Okay, this is your whole angle, your argument z, but it consists of half pi, which is here, and then from here we know that it will be, okay, I draw a straight line. It is here, this part, plus this part. Okay, there are three angles plus together. So how to get these three angles? Okay, firstly, we know that here, this triangle, this is square root 7. Right? Here is 1. Then we can find this as alpha. Okay, this is, let's say, theta. So my alpha, the opposite side is 1. Adjacent side is square root 7. But then for theta, we know that the radius is 2. That means here is 2. And then this length, right, this length can be found using Pythagoras theorem, which is square root 7, square of square root 7 plus plus 1 squared. So now my argument z, I will write argument z equals to theta plus alpha plus half pi. So theta plus alpha plus half pi. Okay, how to find the theta? So before we get the theta, we have to get the alpha first lah. So alpha is basically opposite over adjacent. So opposite over adjacent is tangent. So tangent alpha is 1 over square root 7. Right? So the alpha is going to be inverse tangent 1 over square root 7. Then to get the theta, we need to find the length here. This is the length. Let's say this is the u. Basically, this is a u. So OU, right? Using Pythagoras theorem. So OU equals to square root of 1 square plus square of square root 7. That means you are getting 1 plus 7 square root 8. So the square root 8 is basically 2 square root 2. Now I need to get my theta right now. So based on here, my theta, I have opposite sides, which is the purple color, which is 2 here. And then I have found this length. Okay, this is square root 8. So I have opposite, and here is the 90 degrees. So opposite and hypotenuse. So opposite hypotenuse, it should be sine. So I will get sine theta. Sine theta equals to opposite is 2, hypotenuse is 2 root 2. That means I'm getting 1 over square root 2. Okay, so now my theta is basically inverse sine 1 over square root 2, which is pi over 4. So therefore, this is pi over 4. Alpha is inverse tangent 1 over square root 7, then plus pi over 2. So now you need to leave your answer in radians. Therefore, when you plus all this together, it becomes 2.72 radians. Okay? Alright, so that's all for this video. Thank you for watching. If you enjoy my video, then please subscribe to my channel and stay tuned for more upcoming videos. Thank you. Bye.